In our very first lesson, we'll talk just a little bit about what probability is, how we define our terms, and we'll take a look at an example as we go. So in this lesson, we're going to talk about what a random experiment is, and what we mean by a sample space, what we mean by an event, and what we mean by a random variable. And we'll use a simple example to elaborate on each of these things. So a random experiment is any activity, process, or occurrence whose outcome is uncertain. So what does that mean? If there's anything going on where you don't know what's going to happen, we use probability to model that situation. That's the idea of a random experiment. Common examples: flipping a coin, drawing a number out of a hat, rolling a die, you name it. If it's got uncertainty, we can model it with a random experiment. So the simple example that we'll consider as we go here is the case where we roll a six-sided die. The sample space then is a list of all the possible outcomes. So when you roll a die, you could get a 1, a 2, a 3, a 4, a 5, or a 6. That's the sample space. Those are the 6 possible outcomes when we roll a six-sided die. An event can be a little bit more complicated than that, and this is where we need to be careful with our terms. So an event can be any subset of outcomes in the sample space. So let's consider some examples with our simple rolling a six-sided die. One event we could have is that we roll a 4. Right? In that case, an outcome is an event. Right? So each outcome can be considered an event. However, I could also say, what if I roll an odd number? That's an event. In this case, that's an event that includes the subset 1, 3, or 5. Along with that, I could have the event that an even number occurs, 2, 4, or 6. A prime number occurs, 2, 3, or 5. And of course, don't make the mistake of thinking that 1 is a prime number. By definition, it's not. I could have a perfect number occur, which is a 6. If you're curious, a perfect number is the sum of all of its proper factors. Or I could have any factor of 15 occur. Right? So that would include 1, 3, and 5 here. That provides a good example where we can actually define our event in a different way, but get the same list of outcomes as a different event. So an odd number occurs, 1, 3, 5. Factors of 15 occur, 1, 3, 5. So whether you would consider that the same event or two different events is up to you. That's a philosophical issue. But in either case, we get the same list of outcomes in our subset. A random variable, then, is just the assignment of a numerical value to each of the outcomes of the experiment. So when we're rolling our six-sided die, the obvious way to define our random variable x would be to say x is the number that is shown on the die. That's not the only way we could do it, though. Here's a less obvious one. We could say if we roll an odd number, define x to be 1, and if we roll an even number, define x to be -1. So you might do something like that in the case where you're playing a game, and you roll a die, and the winner, if you roll an odd number, you win $1, and if you roll an even number, you lose $1. Right? And there are plenty of other ways that you could assign a value to each of the outcomes for the roll of a die. These are just 2 examples. Just one tiny bit about notation. We'll use this notation here shown on the screen, where we use a capital P to indicate probability, and then in parentheses we describe the event whose probability we're talking about. And then we'll say equals a value, and that's the probability assigned to that event. So for example, with our six-sided die, we might say, what's the probability of rolling a number greater than 4? So we would say P of x greater than 4 equals 1/3. Since there is a 5 and a 6, if it's a fair die, the probability is 2 out of 6, or 1/3.